Here comes the application of area. How could that possibly have an application? There's a lot of application to it. And here's one that I use in this class. It says, using production and geological data, the management of an oil company estimates that oil will be pumped from a producing field at a rate given by R of T is dBdt equals 100 over T plus 10 plus 10, where T is between 0 and 15 years. R of T is the rate of production in thousands of barrels per year, T years after pumping begins. So they're going to start an oil production at a specific geological location, pumping oil out for 15 years, and we know how much we're producing per day. We're supposed to graph this function and then find the area and interpret it. Okay, here we go. I graphed this on the calculator. So when you graph this, we're going to graph this right here on the calculator. Put that in there correctly. Make sure you put parentheses here when you put it into your calculator. And we only have to graph it between 0 and 15, so make sure you go 0 to 15 here by 5s, and 0 to 20 by 5s. That seemed to work. Label your axes. This is thousands of barrels per year, and this is years after pumping begins. All right, so you can pause this. Make sure you get this in your calculator. Now, what I did was I looked at my chart to plot some points here. That's the chart in my calculator. Now we're supposed to find the area. It says, find the area between the graph of R and the t-axis over the interval from 5 to 10. So that's just a part of this. We still graph it from 0 to 15, but it wants us to find this area from 5 to 10. Area is shaded. Looks like a rectangular, except for this is curved. And to find that area, it's going to be the integral of this function that you drew from 5 to 10. Now this one, if I do this one, this is an ln, so it's going to be 100 ln absolute value t plus 10 plus 10t. All right, this is the first time we had a ln, because the integral of 1 over t usually is what we have here. We happen to have a t plus 10, so you have to kind of trust me on that one. And then the integral of 10 is 10t, and notice the integral sign is gone, and I'm going to go from 5 to 10. So if I plug in 10, I get 100 ln of the absolute value of 10 plus 10. Okay, I've got too many lines going on. Plus 10 times 10 minus, now I'm going to plug 5 into that, so that's going to be minus in parentheses 100 ln of absolute value of 5 plus 10 plus 10 times 5. So heavy in arithmetic here. Equals 100 ln of, isn't that just 20? Yeah. Plus 10 times 10 is 100, minus 100 ln of 15, right there. And absolute value of 15 is 15, and I'm going to subtract 50. All right, now we can put this all in here right now. I just don't want to mess up my signs, so here we go. 100 ln of, what have I put in here, 20? All right, plus 100 minus 100 ln of 15 minus 50. 78.8. All right, now we have to write the meaning. What are the units on this? What are the units on this? A note about units. When you're talking about area, you're talking about kind of multiplying the width times the height here over a period of time. So this is going to be thousands of barrels per year on the y-axis, multiply by years. Look at that. It's thousands of barrels of years, so it's like a length times a width. So you're doing your x-axis units times your y-axis units. The years cancel and you have thousands of barrels. So I would say between the years 5 and 10, $78.8 thousand barrels of what are we pumping? Oil? Yep, of oil will be pumped. So you're taking a rate of change and multiplying by time, and you're getting a total. So it's like a cumulative amount from 5 to 10, how much in that 5-year period between years 5 and 10, 78.8 thousand barrels of oil will be pumped. See you later.